Hello my dear students, I welcome to my Easy Maths class. Today's topic variation. Already you have come to know what variation is. Already we did a class, number of classes. Okay, so today I am going to show you few outstanding problems, and I think since these were classes are secondary classes, that is already you have basic ideas. So now you should go through these sort of problems. Okay, let's see what is given here. If ax plus by proportional to root xy, then show that ax square plus by square proportional to xy. Okay, this one is given, and we have to find this one, right? Now we can write ax plus by is equal to k root xy, where k is a non-zero constant. K is a non-zero constant. Okay. Now we can write ax plus by root xy, that is equal to k. Or we can write ax as root ax whole square. Root ax whole square plus root by whole square divided by root xy. Now I am doing one thing. I am multiplying both denominator by root 2 root ab, 2 root ab, 2 root ab. So this one becomes 2 root over ab xy. Now by componendo dividendo, we can write root x whole square plus root by whole square plus 2 root ab xy, and here it is root x plus x whole square root by whole square minus 2 root ab xy, that is equal to k plus 2 root ab and k minus 2 root ab. Okay. Now what we are getting? We are getting root ax plus by whole square by root ax minus root by whole square. Okay. This one is k plus 2 root ab and k minus 2 root ab. Right. Now after square rooting, you can get root ax plus root by by root ax minus root by. Okay. Here this one will be k plus 2 root ab and k minus 2 root ab. Right. That is equal to, we can consider as n. Right. We can consider n. Since this entire term is nothing but a constant, so we can just simply assume this entire constant as n. So you can replace this entire term by n now. Now again by componendo dividendo. Again by componendo dividendo, you can get 2 root ax by 2 root by. that is equal to n plus 1, n minus 1. Now we can write, from here we can write 2 got cancelled, and then after squaring both sides we can get ax by by is equal to n plus 1 by n minus 1 whole square. Okay, now we can write x by y is equal to n plus 1 n minus 1 whole square b by a, that is equal to, you can consider as m. So x is equal to my. Okay, so x is equal to now my. We got x is equal to my. What to show? We have to show ax square plus by square proportional to, that is xy. So now, therefore we can write ax square plus by square by xy. Just x will be replaced by my. All the x will be replaced by my. Okay, so this one will be a m square y square plus b square y square, and here it is a m y and y. Ultimately this one becoming, taking y square comma, a m square plus b square, and here it is a m. Now this entire term is constant because y square get cancelled, so the entire term remain is constant. So therefore we can write ax square plus by square proportional to xy. Okay, so this particular problem is very important as well as interesting, right? You can just see how componendo dividendo are being implemented here. This is the first thing. Second thing is, while doing variation, you have to focus enough what to do, what to find out. Okay, so ultimately from here, after doing this sort of all those steps, we have found x is equal to my, right? X is equal to my. Now this x is being replaced by my. We got this ax square plus by square proportional to xy, right? This one is a bit harder, but very interesting as important, and important as well as. Okay, I'll be back with another problem. Here is another interesting problem. First go through the problem. What is given? If ax square plus 2hxy plus by square proportional to z square and lx plus my proportional to z, where a, b, l, m all are constant, then prove that x proportional to y. Okay, then prove that x proportional to y. Now we can do one thing. We can write here ax square plus 2hxy plus by square is equal to k1z square. Okay, and here you can write lx plus my is equal to k2z. Okay, where k1, k2 non-zero constant. Right. Now we are doing one thing. By 1 by 2 we can do one thing. Ax square plus 2hxy plus by square by, here you can write this one is 2. Now I'm doing one thing, 1 by 2 square. I'm doing 1 by 2 square. Means Lx plus my whole square. That is equal to k1z square by k2 squared z square. Okay. That is equal to, we can write k. K1, K2 are nothing but constant. Right? Now, I'm doing one thing. After cross multiplication, we can get ax square 2hxy plus by square is equal to k. This one is L square x square m square y square 2 lmxy. Okay. Now I am taking all the terms to the left. What we are getting? X square a minus kl square plus 2 xy h minus lm plus y square b minus m square. K here, k here, that is equal to 0. Now we can do one thing. All of you know these terms are nothing but constant terms. These terms are nothing but constant terms. So, for the sake of calculation, we can consider these terms as, say, PQR. Okay, now you can write, say, PX square plus, say, QXY plus RY square, that is equal to 0. Now dividing both by y square, what we are getting? Dividing both by y square, we can get, if we divide the entire term by y square, we can get p x by y whole square plus q x by y plus r, that is equal to 0. Now we can do one thing. X by y is variable term. Here it is whole square, here it is x by y only, and it is constant term r. It is like ax square plus bx plus c, like quadratic equation. Okay, and all of you know how to find the value of x. Just for example, in case of ax square plus bx plus c is equal to 0, right, by Sridharacharya's method. Now we can write x by y is equal to, that is x is equal to minus b plus minus root over b square minus 4ac by 2a, isn't it? So in this way, minus b here is minus q plus minus root over q square minus 4pr by twice p. And all of you know this entire expression is nothing but a constant term, isn't it? So you can write this one is nothing but constant term. Clear? Therefore, we can write x proportional to y. Okay. This particular problem is a bit critical and interesting. Twisting is there in most of the lines. Try to understand. Here the question was, this was ax square plus 2hxy plus by square. Here that is equal to k1 z square. where k1 is non-zero variation constant. Here Lx plus My is equal to, I have considered k2z, where k2 is also non-zero variation constant. Now what I am doing, considering this relation as 1 and this relation as 2, by doing 1 by 2 square, that is ax square plus 2hxy plus by square by Lx plus My whole square is equal to k1 by z square, k2 by z square got cancelled, and then this one is nothing but a constant term. Here it is being considered as k. Okay. Now, after cross multiplication and taking all the terms at all left, here taking x square common, you can do one thing, my dear students. You can do all these particular calculations elaborately. Okay. Now here, after taking x square common, we got a minus kl square, and then by taking 2xy common, we got h minus klm, and by taking y square common, b minus km square, that is equal to 0. All of you know very well that this entire term is nothing but constant. So you can write this PQR are nothing but PQR non-zero variation constants. Non-zero variation constants. Okay, this PQR non-zero variation constants. Okay. Now this entire term looks like a quadratic equation, isn't it? What we did here, we divide both the term, both side by y square. Px square plus qxy plus ry square divided by y square, and here 0 by y square. Ultimately, we got px by y whole square, qx by y, and r. Right. Here the only variable term is x by y. X by y is the variable term. This p, q, r all are constants. Right. Now by implementing Sridhar formula, you know what the formula is. For a quadratic equation, ax square plus bx plus c is equal to 0. X is equal to minus b plus minus root over b square minus 4ac by 2a. So in this way, we got x by y is equal to minus b, here b is q, root over b square minus 4ac, that is here q square minus 4pr by 2p. Okay. All this entire term is constant. So x by y is equal to constant. So you can write x proportional to y. Okay. So please go through all the lines carefully and do it by your own, and do all the calculations. Okay. After completing these sort of problems, you will be immense confident. That I can assure you. Okay. For today, this one is over. This class is over. And soon we will meet again with another interesting topics. Till then, goodbye.